All right, let's dive right in. We're going to tackle a topic it's pretty much changing everything: machine learning. Now, it might sound super complicated, but really, when you boil it all down, it's about one big, fascinating question. Seriously, just think about that for a second. How does a machine, just a bunch of code and circuits, actually get smarter all on its own, without some programmers sitting there constantly updating its code for every single new thing it encounters? That's the puzzle we're going to unpack today. And here it is, the core idea. Machine learning is all about giving systems this power to automatically learn and get better just from experience. And the phrase you really got to latch onto is without being explicitly programmed. So instead of us writing a rule for every possible outcome, we're basically teaching the computer how to write its own rules based on the data it sees. And that right there is a total game changer.
So, if we're going to teach a machine, how do we do it? Where do you even start? Well, it turns out there's not just one way to go about it. There are actually three main paths, or you could say three different teaching styles.
The best way to get a handle on the first two is to think of them as two totally different kinds of students. On one hand, you've got supervised learning. This is like a student who has a teacher and an answer key. You give the machine a ton of data that's already labeled correctly. This is a cat, this is a dog. It learns by studying these perfect examples. Then you have unsupervised learning, which is the complete opposite. It's like giving a student a massive library with no instructions and just saying, go find something interesting. The machine has to figure out the patterns all by itself.
So, what can you do with this teacher-led style? Well, it's awesome at two main things. First is classification, which is basically just sorting stuff. Is this email spam or not spam? It's all about those is it A or is it B questions. The other big one is regression. This is for when you need to predict a number. Like, how much is this house going to sell for? Or how many people are going to walk into this store next Tuesday? Now, over on the unsupervised side, the tools are different because the goal is pure discovery. You've got clustering, which is kind of like a detective. It sifts through all your data and finds these hidden groups you didn't even know were there, like different types of customers based on what they buy. And then there's dimension reduction, which, it sounds complicated, but it's really just about simplifying things, finding the most important signals in a whole ocean of noisy data.
Okay, but there's a third way, and this one is a totally different beast: reinforcement learning. Forget textbooks. This is more like how you'd train a puppy. The machine, we call it an agent, just tries stuff out in its environment. If it does something good, it gets a treat, a reward. If it does something bad, it gets a penalty. And through a whole lot of trial and error, it just figures out how to get the most treats. This is exactly how AI learns to master complex games or control a robot arm.
Right, so we've got the three teaching styles down, but what's actually going on inside the machine? What does the process of learning actually look like? Let's take a peek under the hood at the learning loop. It's really this simple, powerful cycle that just goes on and on. First, the algorithm takes a guess. It makes a prediction. Then, step 2, something called an error function checks that guess and calculates exactly how wrong it was. And finally, this is where the magic happens. It uses that error to tweak itself. It adjusts all these little internal knobs or weights to make sure its next guess is just a little bit closer to the right answer. And then it does it again and again, thousands, maybe millions of times. And that's really the heart of it all. This quote from UC Berkeley just nails it. The key word is iteratively. The machine isn't just learning something once and calling it a day. It is constantly, endlessly refining itself through this loop of guess, check, and adjust. Every single cycle makes it just a tiny bit smarter. Okay, so we know the process now, but what are the actual tools doing the work? Well, those are the algorithms. They're the specific recipes that make this whole learning thing possible. So let's meet a couple of the most popular tools in the toolbox. First up, you have decision trees. And honestly, the easiest way to picture these is just like a flowchart. The algorithm just asks a whole bunch of simple branching yes or no questions to get to an answer. Like if it's deciding on a loan, it might ask, is the credit score over 700? Yes. Okay, is their income over 50K? No. And it just keeps going down the branches till it reaches a final decision. And then you have the heavy hitters, neural networks. These things are actually inspired by our own brains with all these layers of connected nodes that pass signals to each other. They are incredibly good at finding really, really subtle patterns in huge amounts of data. This is the tech behind stuff like recognizing faces in photos or translating languages on the fly. And this brings us to a really important trade-off. See, the great thing about a decision tree is that it's easy to understand. We can literally follow the path it took and see exactly why it made its choice. A neural network, on the other hand, is often called the black box. It can give you a scarily accurate answer, but its internal logic is so complex with millions of these little connections that it's almost impossible for a person to truly understand how it got there.
Of course, the toolbox is packed with other stuff too. You've got classics like linear regression, which is your go-to for predicting numbers, like a house price. For those simple yes-no questions, there's logistic regression, and of course, you've got those clustering algorithms we talked about, the data detectives that find hidden groups you never even knew were there. All right, so let's zoom all the way back out for a second. We've talked about the teaching styles, the learning process, the actual tools. But why should you care? Why is this one of the most important technologies of our lifetime? What's the big picture?
So here's the takeaway. Machine learning, it isn't magic. It's a process. It's about letting systems improve from experience. We saw there are 3 main ways to teach them: supervised, unsupervised, and reinforcement. And we know that learning happens in that constant loop: predict, check the error, and then adjust. And finally, to do all that, there's a whole toolbox of different algorithms, each one perfect for a specific kind of job.
When you step back and look at it, what we've really done is build machines that can learn. They're incredibly powerful tools, but what we choose to teach them, the data we feed them, the problems we ask them to solve, well, that part is completely on us. Which really leaves us with the biggest question of all, doesn't it? What's next?